reflection by prism. We'll take one prism and this angle is called angle of prism. This angle A is called angle of prism. This is incident ray of a light. This one is normal to this surface. So refractive index of this prism more than air, outside medium we am taking air, and this one mu. So light ray moving from rarer medium to denser medium. So light ray went towards normal. This is light ray. Now this light ray moving from denser to rarer. If you look at this one, it's moving from denser to rarer. So it will went away from the normal. If I join these two normal, and let's say this angle is theta, this angle theta, and this angle of prism A. So if prism is not there, this light ray is supposed to move straight like this, supposed to move straight like this. If prism is not there, it's supposed to move straight. If prism is there, this light ray going like this, it means this is deviation, angle of deviation. I am writing this one delta. This angle A, so this angle will be R. And this angle, I am taking angle of emergence, so this angle I am taking R dash. So if you look at this angle I, so this total angle has to be I. It means this angle should be equal to I minus R. Similarly, this angle E, so this angle should be this one, E minus R dash. So if I use exterior angle property over here, then if you look at this triangle, this diagram, this triangle, if you look at this one, this angle is delta, this angle I minus R, this one E minus R dash. So using exterior angle property, I can write delta is equal to I minus R plus E minus R dash. It means delta is equal to I plus E minus R plus R dash. And delta is what? Angle of deviation. Now, if you look at this triangle, not this triangle, if you look at this one, this let's say this is P, this one Q, this one R, this one S. So if I make another diagram for this one, so this is 90, this one also 90, means this angle 90, this angle 90, this angle A, this angle theta. So I can write A plus theta is equal to 180 degree. And if you look at this triangle, in this diagram, I'm talking about this triangle, this one. So this angle is R, this angle R dash, this angle theta. It means we can write R plus R dash plus theta is equal to 180, equation 2. If I solve this two equation, I'll get R plus R dash is equal to E. And if you look at this equation, this one, I can write delta is equal to I plus E minus E. Now if I did minimum deviation, means this delta should be minimum. In that case, this ray, this light ray should be parallel to this baseline. This light ray should be parallel to baseline. It means I is equal to E and R is equal to R dash. This is for minimum deviation. For minimum deviation. Minimum deviation. So for minimum deviation, I is equal to E and R is equal to R dash. Now look at this one. In place of I plus E, I can write only 2I. So D is equal to 2I minus E. In place of E, I am writing I, so this becomes 2I. So I is equal to delta M plus A divided by 2. And for minimum deviation, R is equal to R dash. So in this equation, in place of R dash, I am writing R only. So R plus R is equal to A. It means 2R is equal to A. It means R is equal to A divided by 2. Now if you see this side PN side of this prism, I am applying law of refraction, means Snell's law. So I'll get, in this one I am applying Snell's law in PN. So I'll get mu1 into sin I is equal to mu2 into sin R. So if I apply this one over here, so I'll get mu1 sin I is equal to mu2 into sin R. It means mu1, so it means mu1 is refractive index of this rarer medium and mu2 refractive index of this prism. I is what? Angle of incident, and R angle of refraction over here. So I can write mu2 by mu1 is equal to sin I divided by sin R. Sin R. So I can also write this thing in place of I, I'll put this value. In place of R, I'll put this value. So I'll get mu2 by mu1 is equal to sin A plus delta M divided by 2 divided by sin A divided by 2. This is refractive index of a prism. And if outside medium is air, in that case mu1 become 1. So I can write mu is equal to sin A plus delta M divided by 2 divided by sin A by 2. Now let's say this angle of prism is very small. If I assume this angle of prism very small, this angle, it means delta M also is small, this delta M also is small. Like if angle of prism is small and delta M also is small, so if I add 2 small quantity and divide by 2, again it is smaller. So when sin theta is very small, in place of sin theta I can write theta. So if I want, I can write mu is equal to A plus delta M divided by 2 divided by A by 2. When we can write this thing? When angle of prism very small, in place of sin theta I am writing theta, in place of sin A by 2, sin A by 2, in place of sin A by 2, A by 2, in place of sin A plus delta M by 2, A plus delta M by 2. Why? Because this A is very small. So A plus delta M divided by 2 again is smaller than that. So we can write this property. So after solving this one, I'll get delta M is equal to mu minus 1 into A. This is another formula, but this is only applicable if a is very small.